Good morning, children. Sairam. In the previous presentation, we have started with the chapter redox reaction. I have explained you what is oxidation, what is reduction in terms of electron transfer as well as in terms of oxygen and hydrogen and other electronegative and electropositive species. And we have also learned about the oxidation number and how to find out the oxidation number. This also we have done in the previous portion. Now today I'll be telling you what is meant by a oxidizing agent and a reducing agent. See children, a reagent which increases the oxidation number of an element in a given substance, that reagent is called as an oxidizing agent. That means the substance which is itself getting reduced is called oxidizing agent, and reducing agent is that which itself is getting oxidized. So in a chemical reaction, the substance which is getting oxidized is actually the reducing agent, and the substance which is getting reduced is the oxidizing agent. Now children, the next topic given in the book is types of redox reaction, but this portion has been removed from the syllabus. So the last topic of your chapter is balancing of redox reaction. Now the redox reaction balancing, it can be done by two different methods. First is by the electron, you can see here. Two methods are there for the balancing of redox reaction. One of this method, it is based on the change in oxidation number of the reducing agent and oxidizing agent, and the other is based on the splitting of redox reaction in two equal halves. Now both these methods are there in the use. Now first of all, we are starting with the oxidation number method. Now see, there are steps that have to be followed while balancing a chemical reaction by the oxidation number method. The first step is to write the correct formulas of each of the reactants and the product. In the second step, we have to allot the oxidation numbers and to find out which substance is getting oxidized and which substance is getting reduced. In the third step, we actually calculate the increase or decrease in the oxidation number per atom for the entire molecule or ion, and then we multiply. If the number of electron transferred are not equal, then we multiply a particular reactant with a particular number to make the number of electron transfer equal. In the fourth step, the involvement of ions, if in the reaction is taking place in water, we add the hydrogen ion or OH negative ion to the side in which they are deficient. In the fifth step, we make the number of hydrogen atoms in the expression on the two sides equal by adding water molecule to the reactants or to the product wherever it is required, and is the final you can say the step for the chemical reaction. Now an example is there for you. Now we'll be balancing the chemical equation Cr2O7 2 negative, which is in aqueous medium, reacts with SO3 2 negative in aqueous medium to give Cr3 positive and SO4 2 negative. Now first step is to write the skeletal equation. This is the skeletal equation. In the second step, we allot the oxidation numbers to all the species. Here oxidation number of chromium on the left hand side is 6 positive. Oxygen is 2 negative, sulfur is 4 positive, oxygen is 2 negative. On the right hand side, chromium is 3 positive and sulfur is 6 positive. That means the change in oxidation number occurs in case of chromium and sulfur. Chromium is converting from 6 positive to 3 positive. Yes, it is for two atoms, it is 6 positive, and this side to balance we multiply with 2. Sulfur is 4 positive, this side sulfur is 6 positive, and to balance them we multiply by 3. In the next step, as the reaction is occurring in the acidic medium, further the ionic charges are not equal on both the sides, so we add H positive ion. The total charge which is present on the left hand side, you all can see, is 2 negative plus 2 negative into 3. 6 negative plus 2 negative is 8 negative. This side the charge is minus 8, and this side the charge is 3 positive into 2 is 6 positive, and 2 negative into 3 is 6 negative. That means here it is minus 8 and this side it is not there. So we add 8 positive ions, that is 8 H ions on the left hand side. Now finally we count the hydrogen atom and add appropriate number of water molecules on the right to achieve the balance. Now in the final step, the skeletal equation is in the final step this equation is written, and to add to make the number of hydrogen atom equal, we have added 4 water molecules on the right hand side. So your equation is now balanced. This is the way how we balance by the oxidation number method. Now next is the half reaction method. To balance a reaction with the half reaction method, there are certain steps. In the first step, like for example, we are balancing this equation. Suppose it is Fe2 positive reacts with Cr2O7 2 negative, which gives Fe3 positive and Cr3 positive. We divide the equation into 2 equal half, oxidation half and reduction half. If suppose some water molecule or OH ion is there, we leave that. We only take those substances which are getting oxidized and reduced. Now we balance the atoms other than oxygen and hydrogen in each of the reaction individually for different reactions. Here the oxidation number is already balanced with respect to ion for the reduction half reaction. So we multiply 3 positive by 2, Cr3 positive by 2 to balance the Cr ions. Yes, the Cr3 positive is multiplied by 2. And in the next step, as the reaction is occurring in the acidic medium, we add a water molecule to balance oxygen and H positive to balance the hydrogen atoms. Now electrons are added to make the reaction number of electron transfer equal. Here we all can see that Fe2 positive is converted to 3 positive, so 1 electron is added here, and here 6 positive electrons are added, and then we in the last step then this iron equation is multiplied by 6 in order to make this and this equal, and then we add the two equation and see whether the number of electron transferred are equal or not. We cancel the 2 electrons, and then the electron is the reaction is in terms of charge it is balanced. For basic medium, what we do is first we balance the atom as it is done in the acidic medium, and then for each H positive ion we add the equal number of OH negative ion on both sides of the equation, where H positive and OH negative appear on the same side of the equation, and then we combine these to give the water molecule. This is how we balance the chemical equation. Now children, the next topic that is given to you in this book is the electrochemical cell, but the electrochemical cell is also removed from the syllabus. The last topic for this year according to the CBSE is only your up to the balancing of chemical equation. So I'll wind up with the presentation today, and in the next presentation we'll be starting with the next chapter. Thank you and Sai Ram.